Divine Public School. I'm your science teacher. We are learning chapter 11, The Human and the Colorful World. Yesterday we have seen how does the phenomena work in the dispersion of light, right? That how does a light disperse, split into 7 constituent colors. We call it this as dispersion, right? And then I told you that the red color light velocity is maximum, and that's why the bending of or the refraction of red color is minimum, and so is the violet color light velocity is minimum. That's why the refraction of that particular light is maximum. This, because of this all, it separate into constituent colors. Then we are going to see how does a rainbow is formed. Okay, now the light which is coming from the sun, we call it as a white light, right? We call it as a white light. Again, that's the light we uses in a prism, and the white light split into 7 constituent colors. But the question here is, how does a rainbow form? Okay, how does a rainbow form? So let me just tell you this thing. Okay, so yesterday we saw this with the inverted prism. Now a rainbow is a natural spectrum. What we have created through prism with an artificial spectrum, right? This is a natural spectrum. Now when you can see a rainbow? Definitely not during the rain. Always understand, not during the rain, after the rain. The rainbow is always formed after the rainfall, and when a tiny water drops are coming from the clouds. Okay, so it is caused due to the dispersion of sunlight by a tiny water droplets. First of all, rainbow, right? Rainbow always forms after the rainfall, right? When there is sun also, right? And a tiny water droplets. So if the sun is here, always remember, rainbow always forms, right? Rainbow always forms in the opposite direction of, it never be there on the same side. Remember, rainbow can never be here. It is always there on the opposite side. So if sun is in the east, right, the rainbow is on this side. So it always forms on the opposite side. Okay, first of all. So for a rainbow, right, a dispersion is needed, means a 7 constituent colors has been splitted. Second thing, so that's why the sunlight is required. So if you can see, many a times the rain happen right now, but still, do you ever observe a rainbow? No. So it should require certain particular condition, then only a rainbow forms. So first condition, the water droplets are tiny. Second condition, the sunlight has to be there. Now what exactly? And third, I told you a rainbow is always formed in the direction opposite to that of a sun. Now this tiny water droplets acts like a small prism. So basically this water droplets acts like a prism. Now what happened into the raindrop? First of all, understand that thing. Okay, so let's say this is your raindrop. Okay, this is your raindrop. Wait, so this is your raindrop. Now what happens whenever a white light comes, okay, now for what does the first thing happen is the light, right, it bend. So basically two phenomena happen here. One is refraction, right, and dispersion. So two things happen at the same time. One is refraction, another is dispersion. See, the light split also and light bend also, because the medium changes. The light is going from air to The light is going from air to water. So definitely the medium changes. So it split. So it will split. So again I am showing you. So it split. So it incident like this, right? But 7 colors get separated like this. Now what happens is this light, right? So consider this green light as violet and this one is already red. Now what happens is you cannot see a rainbow at this moment. Then what happens is there is internal reflection. Now you must be wondering what I am talking. Yes. So what does the first thing happen? First thing is refraction, right, and dispersion. Second is internal reflection. Internal reflection. You must be wondering, sir, which is a water drop? It is transparent. Internal reflection. Yes. Do you ever observe your shadow, not shadow, your image on water? You must have heard a famous story of a lion and a rabbit, okay, that he jumps into the well and all. Here also, or you, when you bucket full of water or in a pond, when you peep inside, you see your own image. Do you think how does your image is formed? It is because of internal reflection. So from here, the light, right, has an internal reflection. Okay, so light has an internal reflection. Okay, then so internal reflection. Then from here what happen is again refraction happen, and from here what happen is a refraction. Okay. Fine. So this is actually what happened. Why does it get separated more? Because now the light is moving from rare medium to dense medium, so it moves away from the normal, and over there it moves towards the normal, and this is what happened exactly in a rainbow. See, first the sunlight comes, when it enters into a raindrop, two things happen, right? A refraction in and dispersion. In the raindrop, internal reflection happen, and at the end refraction happen, and this is how you can see colors. Okay, I hope you understand how does this thing happen, right? So this three phenomena, when it happens simultaneously, then only you can see a rainbow. Now understand how difficult it is there to see a rainbow. Okay, so when three phenomena happen at this point, then only you can see a rainbow. First, refraction and dispersion, internal reflection and refraction. Normally people don't speak this refraction, but still that's okay. So people normally say dispersion, internal reflection and refraction. Reflection, huh? Understand this thing, it's not internal reflection. Okay, so this is what happened. So how does the rainbow form? The tiny droplets acts like a prism. There should be a sunlight. When these two combination happen, the drop acts like a prism. When a light enters into the water drop, refraction and dispersion happens. Hence, the light split into 7 constituent colors. Then it has an internal reflection, and finally, after refraction, you can see a rainbow. Now, what we are going to see the next is atmospheric refraction. Now, this is a wonderful phenomenon. Understand this thing. Atmospheric refraction. Now, you must be wondering, refraction happens in atmosphere? Yes, refraction happens in atmosphere. Okay. Now, You must have seen, have you seen any on a hot air or on a fire? Have you seen on a fire, right? When there is a fire somewhere and you see the air above that fire is hotter, right? And when you try to see from that air, what you can observe, the image is moving or it is not clear. Have you observed? Or on a radiator, radiator is on this thing. In summer also on a coal tar road, right? The roads which are made up of coal tar. When you see from a distance, there is some hot air you can see, and on that hot air you can see some images which is not clear, right? The same thing you must have observed in a movies also, that on in the desert, above that sand, right, the person can see a water, but it's not actually, there is no water when he go. What does all these things? This is atmospheric refraction. What happen in atmospheric refraction? See, this is our air, okay, this is our air. Understand this thing very properly, because whatever all phenomena we are going to see, it is based on this only. So this is different layers of air, right? This is earth here and it has different layers of air, okay. See, so the first thing is the apparent random wavering of a turbulent steam or a hot water fire in a or a radiator, right? The air just above the fire becomes hotter than the air further in. The hotter air is lighter, means less dense, and the cooler air. So the refractive index. So when the air is hot, will it be more dense or less dense? Dense means what? We say dense forest. Dense means together. So in hotter air, the particles are far from each other, so it is less dense. While in a cooler air, the particles are near to each other, so it is more dense. Right? Since the physical condition of the refractive mediums are not stationary, so basically one is less dense, other is more dense. So definitely there is some atmospheric refraction. Refraction is going to happen because of density. You know, I told you, why does the light bend? Light bend because of change in the density. As you know, the densities are getting a change. So if your density is changing, definitely the refraction is going to happen. The same thing happen, right? This wavering happen because of atmospheric refraction. So if you understand this phenomena, the air above the earth is hotter during the daytime, right? And the air above it is cooler. Why it is cooler? Right? Because when the earth is heated, definitely the air above it get heated, right? So what happen is, have a look, okay. So this is what they are trying to teach you, that the twinkling of the star is because of atmospheric refraction. Understand, this is a very important question. So twinkling of the star, it is because of atmospheric refraction, right? Now the straight light, the starlight, on entering the earth's atmosphere undergoes refraction continuously before it reaches the earth, right? So before it reaches the earth, it is continuous refraction happen. Why? Right? So see, let me show you. Now see, let's say this is our star. Let me remove this. So this is your star. Now when a light comes from a star, it ideally should come straight, right? Let's say there is a person here. Now suppose this person is looking at the star. So first of all, in order to see a star, the light from the star should come to your eyes. So let's say this light is coming from star straight to your eyes, but you know this is not actually going to happen, right? This is not actually going to happen. So what is going to happen? Okay, let me show you. Let me redraw it here. Okay. So what happens is, actually when a light comes to the atmosphere, you know, the density is changing at every point. The density is changing. So here, when a light comes from sun, right, when it just enter, the light density changes. So what happens is, the light keep on bending, right? It keep on bending, right? Before it reaches to us, the light keep on bending, right? It will not come straight. The light keep on bending. Why bending? Because of atmospheric refraction. The density at every few kilometers layer, the density of air changes. You know, right? The air near the earth is hotter, so it is less dense, and the air near above it, it is more dense, right? The air above it is more dense. So what happens is, what our eye do, why I always try to see it straight. So what our eye do, our eye always try to see straight. So our eye always try to see straight. So the star which is here, we don't look that star at that place. We look at the star, we see the star at this place. Okay. So we see the star which is down, we can see the star here. Okay. So what I am telling you is, the star which is there, right? Right? The star which is here at the original position, we do not see the star. So what do you call this place where you can see the star? Is it the actual position? No. This is the actual position, and this is apparent position. Again, why we can see our star there? The reason is, the reason is, the reason is not The reason is not because of that. The reason is that the star, why does a star look at that place? Because of this thing. Okay. So always understand that whenever you see this thing, the star looks right above it. So that is the apparent position, and this is the actual position. Now, so understand this small phenomena of apparent and actual position. This happened because of atmospheric refraction, and because of the light keeps on bending, we can see the position above it, right? But still the confusion is, why does the stars look twinkling? Why does the stars look twinkling? Right? The stars look twinkling because of, right, this reason. So this is the reason. Now what happens? Suppose the air is coming, right? The change, the movement of air. Now the air comes. So when the movement of air comes, the density is mixing. So the hotter air mixed with the cooler air mixed with the hotter air. So the density changes. So what happens is, the apparent position changes. Sometimes you look the star at here, sometimes you look at the star here, sometimes you look. The star keeps on changing its place. Actual star is there only, but because of atmospheric refraction, its apparent position changes. Yes, because of it atmospheric refraction, the atmospheric changes, and because of that reason, we can see star at different places and actual and apparent position. Actual and the apparent position. And this is the reason we look stars twinkling, because the star is so far from us, we cannot actually make a difference between the actual and the apparent position, right? If it is near, then we can make out the actual and the apparent position difference, but as it is very far from us, we cannot make out the actual and the apparent position. Okay. So because of that reason, you can see star at that difference. We can see star, the difference between that. Okay. So I hope you are getting what I am trying to say. This is how the stars twinkle, and this is how we can see stars twinkling, right? So I hope you are getting what I am trying to say. Again, understand this video very well, right? So two things, because of atmospheric refraction, the twinkling happens, right? Because of atmospheric refraction, the twinkling happens. Actual and the apparent position. Okay, so actual and the apparent position things comes from this thing. Okay, so that is what I am trying to put my efforts into it, and I hope you are getting what I am trying to say. So actual and the apparent position things comes in this way, and you can get what I am trying to say. Okay, so hope you are getting what I am trying to put an effort into it. Look at it, ask me questions if you have any. Thank you.